Okay, this is a problem from practice 8.2.03, and it's problem number one, and slide two, I think. So, but it's problem one. Okay, and I'm going to have you draw it out. It does have it has graph paper, it has a grid on Amplify, but I'm just going to have you draw it without a grid. So we have, let me use a different color. It gives us two triangles. And then it gives us another triangle going this way. It's about right here. So do your best to draw these triangles. Take your time, draw them, try to draw them like I have them here. And then the question is there a transformation, is there a transformation or sequence of transformations sorry, I'm going off the page, that, and I'm abbreviating the question because you can see it at Amplify anyways. Is there a transformation or sequence of transformations that can move one figure onto the other? Okay, and you have to think about, and it does give you the examples of transformations. It says translations, rotations, reflections, or dilations. And dilations, remember, are the new one that we're talking about in this unit. Dilations mean that you either get bigger or you get smaller, but you stay the same shape. Okay, and there is a grid so you can tell how long these sides are. So this side on the grid is 4. And the corresponding side on this one is this right here. So you see that this is the straight one that makes a 90-degree angle with the short side. So that's 4, and on this one it's 6. And on the grid, you'll be able to see it when you do problem 1. This one is 2, and this one is 3. So we're trying to figure out if this can move on to this. Okay, so if you look at it, you can see that if this rotates, if we rotate this 90 degrees, you do end up looking like you have a shape that matches. So if you do rotate it, this would go down here, and then this would go like this, and then you would rotate it there. So that's if you were just to rotate it, that's where it would land right there. And you can use patty paper if you don't believe me, because I usually use patty paper also. Um, but I practiced this one already. Anyway, so we think maybe, I mean, based on the looks, it does look like it matches, but we really have to be sure. So if we want to know if it's a scale copy, which is what it's asking, really. Is there a transformation that can move it onto the other? That's basically asking, is it a scaled copy? And if the answer is yes, then this answer is yes. Is it a scaled copy? Or are they scaled copies? That probably would be better. Are they scaled copies? But that's okay. Okay, so we need to know, is there a scale factor? Is there a scale factor? If there's a scale factor, then it's a scaled copy. Okay, so we know that 4 and 6 are the corresponding sides. So I'm going to put 4. So this is the small triangle, and this is the large triangle. So, oh, that looks like 5. Small. Okay, so the small one has 4. The big one is 6. And the small one for that corresponding side is 2 and 3. So A scale factor basically is saying, okay, do we have 4 times something equals 6? So you can write that as 4x equals 6. Okay, we were kind of talking about that on our warm-ups today and yesterday. So 4x equals 6. So in order to figure out what that is, then we would divide, just like we did before. And if we do 6 divided by 4, if you did that in a calculator, you end up with 1.5. Okay, so I know that 4 times 1.5 equals 6. Now you have to ask yourself, okay, does 2 times 1.5 equal 3? Well, you can try it. Just put in the calculator. 2 times 1.5. Does it equal 3? Yes, it does. It equals 3. Okay, so recap. We know that if this rotates 90 degrees, it's going to be in the same position as this one. It's facing the same direction. And then we have to figure out if it's a scaled copy, because if it's a scaled copy, it can blow up to be the same size as this one. Basically means it's the same shape, different size. So is it a scaled copy? Yes. Do we have a scale factor? Yes. Scale factor is 1.5 because these are 1.5 times less than these. If you multiply this by 1.5, you get these numbers. If there's anything added in the notes, if you want to add that in your notes, you might want to make a sentence like that where you're a scale factor, and we wrote it already before, but a scale factor is a number that you multiply everything by to get the new shape. So if the scale factor is 1.5, then we know that, use a different color again. We know that the answer to the question, is there a transformation or sequence of transformations that you can move one onto the other? The answer is yes. Rotate 90 degrees, small triangle, 90 degrees, let's say small triangle, 90 degrees, let's see, that way is counterclockwise, and dilate, oops, whoa, undo that, and dilate with a scale factor, sorry, this is so messy, of 1.5. So if you have any questions about this, because this is it's a bit of a problem, even though it looks small in Amplify, there's work that you have to do in order to figure it out. You have to do the math. You gotta say, okay, well, can I multiply this by the same number to get the new copy? And in this case, the answer is yes, but you really do have to do work to figure that out. So that's that for that problem. Okay, so this problem is also from practice. Well, it's the same video, so yeah, we're doing another problem from practice 8.2.03. And this is problem number 2, slide 3. It is asking you the same question. So is there a transformation or sequence of translations, rotations, reflections, or dilations that moves the figure onto the other? And this one is like an L shape. So it's a small L and it's like this. So you're drawing this. You're drawing this. It's kind of like that. I'm gonna erase this little extra part. Oops, it erased the whole thing. Okay, and then the other one is 1, 2, 3, 4, 5. I'm doing 6 lines because on the Amplify it's 6 squares. So I'm trying to make it as accurate as possible. Okay, and then goes 1, 2, 3, 4. And okay, about like that. So at a glance, they do look like they are scaled copies. So, but let's make sure. Well, it's asking if it's a transformation, if you can, transform them to go right on top of each other. And so, this was 4. This is 1. This is 1. This is 2. This is 3. This one is 6. This is 4. This is 2. This is 2. And this is 4. Okay. So if you look at this, you can look at it the same way. So is it a scaled copy? Is there a scale factor? All right, so let's find out. So last time we did a little table. I'm gonna try to make it a little bit neater this time. I don't know, we'll see. So this is the small L and this is the large L. Okay. So let's look at, well, we could see that this from here to here, that's twice as big, right? That's 1 times 2. That's 2 times 4. Or 2 times 2 is 4. So that's times 2, 1 times 2. So these go, this this is a times 2 right here. These all are times 2. Okay, so we know 1 times 2 is 2, and then we have a 2 times 4, 2 times 2, sorry, equals 4, and then we have, let's double check. Okay, so if we do this one, that's 3 and 4. So I know, so 1x equals 2, x equals 2. So this is our scale factor. And then we also have 2x. So this one goes here with this. I said I was going to try to make it less messy. I think I'm making it more messy. That is x equals 2, right? 2 times 2 equals 4. This one right here, that would be 3x equals 4. Well, definitely that can't be the same, right? Because you wouldn't multiply it by 2 to get 4. So let's see, we divide by 3, divide by 3, and then if you do this as a division problem, 4 divided by 3 ends up being 1 and 1/3, I think. Or you could put it as a fraction. So x equals 4/3. You could even just leave it as 4/3, but that would be 1 and 1/3. And so there's not a scale factor because this side and this side don't have a scale factor of 2. So 3 times 2 would be 6. So this little L is longer this way than this one as a scaled copy. So this is not a scaled copy. So the answer to this question would be no. The question is, can you perform any translations? So No, these shapes are not scaled copies. Okay, and that's basically what the rest of these problems are in this lesson is basically if you cannot, if you can say that it is a scaled copy, then you can do certain number of transformations to get them to match. And if it's not a scaled copy, then they're never going to match up. No matter what you do, they're just not going to match up. You can't dilate it or rotate it in any way in order for them to match up. So you really do, again, you got to do the math because otherwise you might look at it and go, yeah, it kind of looks the same. Those are scaled copies. And then when you really do the math, you'll figure out that they don't go together. Times two, times 1 1/3. They're not scaled copies. And that's all for that video.